two notes. Going to be volume and application. All right, so the first thing we're going to do is the volume for rectangular prisms or cubes. Here's the formula. It's length times width times height. So very, very simple. So what you would do is volume. You got 9, you've got 17, and then you've got 24. Okay, so L, W, H. And then you just put that into your calculator and you're going to get 3,672. And remember to get the units centimeters, and volume is cubed. Okay? Next thing, find the volume of the figure below. So same deal. You've got your length here, you've got your height here, and then you've got your width here. So volume equals 10 times 14 times 4.5, and you've got 630 inches cubed. Okay? So, now let's talk about other prisms. Okay? The formula here is volume equals big B, which is the area of the base. You've got to get the area of the base first, and then you've got to get the height in between bases. The most important thing is this. Okay, your bases are going to be the same figure. So here, okay, here's base 1 and here's base 2. Okay, the important thing to note is that the base is what connects those two, the height is what connects those two bases. That's what the height is. Okay, so for this one, this image, it's important to say that the height, okay, is going to be 5. Okay, so I'm going to highlight that because it connects the bases. Okay, all right, so we'll put height for that. So the big base area, okay, so is going to be half 12 times 7.3. Okay, so your base is a triangle, right? Okay, so I'm going to put it here. The base is 12, the height is 7.3. The area of a triangle is half base times height. Half base times height. And notice that's little b, so it's the base for that triangle. Okay? So that's going to be about 43.8. And so that's step 1. Step 2 is going to be to take 43.8 times the height times 5. That gives you 219 feet cubed. Okay? Let's try another one. Here is a trapezoid. Again, your height is going to connect the bases. So your height, okay, is that 25 because it connects the bases. All right. So for a trapezoid, our formula is going to be for area. Big area is going to be half height, 17.9, and then length of base 1, top of the base and the bottom of the base. You add those together and you're going to get 447.5. Okay? And then to get the volume, step 2, you are going to do 447, 0.5, times that height, 25, and you're going to get 11,187.5 meters cubed. Okay? So take it one step at a time. Now, let's do cylinders. Cylinders, okay, you have volume equals pi r squared times the height. It's basically the area of the circle, right? And then the height, okay? So, here we go. Remember, we need the radius, okay? Do not just do the diameter. So 11, the radius is going to be, you're going to get 10.5. You're going to get, I'm sorry, not 10.5, you're going to get 5.5. Okay? So now let's do it. Volume equals pi, you've got radius squared, and then times the height, which is 21. Again, the height is that you have two bases, and the height is the line that connects the two bases. Okay? So that's your height. Okay? And then you multiply those together, and you're gonna get 635.25. Pi is the clean version. Or if you multiplied it all out, you're going to get your approximation, which is going to be 1,995.7 meters cubed. Okay? On to the next page. Okay. So now we've got pyramids. Okay? Here we're dealing with the base. These are square pyramids because the base is a square. Okay, I mean a rectangle. All right, so the big B again is area of the base, and H is equal to the height. Okay, so first let's find, step one, let's find the area of the base. Okay, that's pretty simple. Area, here's your base, right? And then that is a rectangle. Okay, so you go 10 times 11, length times width. Okay, and that is 110. Okay, that's step one. Step two would get the volume. Okay, to get the volume, you're going to use 1/3. The area you just found, 110, okay, times the height, which is 16. Okay, all right. So now you're going to get approximately 586.67 inches cubed. Okay. It is important to note that the height of a pyramid is from the top to the bottom. Okay, that's what your height is right there for a pyramid. Okay, so here now we have another pyramid, okay, and this time the bottom is a square, or the base is a square. Okay, so that part is easy. So step one, area of the base equals 14 squared, or side squared, okay, and you're gonna get 196. So area of the base is 196. Step two, you get to do an extra step with this one, because this right here, right, this 25, that is slant height. Okay, that is not real height. That's the slant height. Okay. So now what you have to do is you have to draw the height, like up top, from the top to the center of the base. And guess what this is? This is a right triangle. Okay. So if I take this out, if I pull this triangle out, what you have, the slant is your hypotenuse, 25, and then here, since your whole base is, the length of the base is 14, half of that, which is the base of that right triangle, is 7, so that's going to be 7, and your job is to find the height right there. Okay, so if you do Pythagorean theorem, x squared plus 7 squared equals 25 squared, you're gonna get x as being 24. Okay, so height is now 24. Your height is 24. Okay, so now when you do that, you're gonna do step 2, you're gonna do volume equals 1/3 of 196 times the height you just found. Okay, all right, so that gives you 1,568 feet cubed. All right, let's do our last shape. Let's do cones. Okay, and cones, I think they're pretty easy. The first one, okay, actually let's go over the formula. Volume equals 1/3 pi r squared times the height. Okay, r is radius and h is the height. Let's try a different color. Okay, so here what you're going to do is volume, the third, okay, pi. The radius is given to you, that's 9 squared times 17. Okay? Clean version, just tack pi on at the end, and when you multiply all these numbers, you're going to get 459 pi, or the approximation 1,441.99 yards cubed. Okay? Now, I want you guys to try number 2, okay? Remember, you need to work with radius, all right? Last thing here is an application problem, okay? I want you to try this, okay? But I want you to think about it. You've got two things. You've got to figure one thing out, okay? You've got to figure out the volume of one thing and take it away from another. All right, so try this challenge problem out and we'll talk about it in class.